In this problem, you have two rational functions, and you're trying to find the domain of the composition. In this problem, it's f of g of x. So what we would have is g being inputted into f, or the output of g of x being inputted into f of x. So to find the domain, there's two things we have to think about. First of all, if we were to input a number for x, it would be going into g first. So we need to make sure that g doesn't end up with a 0 in the denominator. So we'll start with the domain of g of x. And like I said, we have to have a non-zero denominator. So that means that in this problem, x cannot be 1, just adding 1 to each side here. So that will make sure that we're not inputting something that's undefined into f of x. Now we need to make sure that we're not inputting something that will wind up with a 0 in the bottom. So one way you could do it is piece things backwards. We cannot have x be a -3, which means the output of g of x cannot be -3, but that might be kind of hard to solve or hard to visualize. So what I recommend is now look at the composition, in this case f of g of x. F is 1 over x plus 3, and instead of x, I'm inputting g of x, which is 9 over x minus 1. So now we have our composition. Now we could go through some steps to really just make this look better, to simplify this. This is a complex fraction or complex rational. So we have a fraction within a fraction. We usually do not like to do that. So what we tend to do to simplify these is multiply everything by the least common denominator. We don't have a denominator up here. We don't have a denominator here. We have one denominator of x minus 1. And so this really seems like a good route to go with, because it's not going to take a lot of work to make this a lot simpler. So now my f of g of x composition is going to have 1 times x minus 1 over this rational expression times x minus 1 plus 3 times x minus 1. And we can do some distributing, and here we can do some canceling. The 1 distributed doesn't make any changes. So we have x minus 1 over 9 plus 3x minus 3. And we can make this a little simpler yet by putting the 3x in front like we like to do. And then 9 minus 3 is 6. So now we have a nice simplified composition of functions, f of g of x. And if we want to see what would make the denominator 0, we just take that 3x plus 6. It cannot equal 0. Oops. So two-step equation, minus 6 and divide by 3, and you're going to get -2. So x cannot be -2. And all the way back here, x cannot be 1. So our domain should be everything except, why don't I just add it to here? X cannot equal -2 or 1.